Yeah, hello everyone. So, good evening. Those of you who are not able to join today's session, so definitely you can join. You can go back and watch the videos later that I will be posting on my YouTube channel. So, no need to worry. I will be starting now. Okay. So, okay, I will just share my screen. Yeah. All right. Fine. So, before starting, I'll make some quick announcements. Before that, let me do some introductions as always. So this course is basic electrical circuits. It's an NPTEL course, and this time it is being hosted by Dr. Gajendranath Chaudhary, and he is a faculty member in the Department of Electrical Engineering at IIT Hyderabad. And myself, I am Mayank Kanupam, and I am a tutor for this course. I hold these discussion sessions. So right now I'm doing my PhD in electrical engineering at IIT Kanpur. Cool. So before proceeding with this week, with week 12's content, so I'll be making some quick announcements. So we'll having an extra session on Thursday. That is, I guess 19th. We'll be having an extra session on Thursday, 19th. Okay. So that will be a 1.5 hour or maybe 1 hour session, but keep your slot free for 2 hours. So it will be from 3 to 5 p.m. and we will be discussing some last year questions and semester questions. Basically, the exam that you will be appearing in, we'll be discussing those questions. So please make sure that you attend that session next, basically the coming Thursday. Okay, on 19th, 3 to 5. Cool. So, mm, yeah. So let's start now. Let's start the session now. So in this, the first question is, basically I'll be discussing some questions based on the content that was covered in week 12. So we learned about second order circuits, right? We learned about the steady state, how to find out the steady state response of a second order circuit. We saw what is a phasor. Okay, we learned about transfer function. We learned about frequency dependent transfer function, basically frequency response of a system, right? The second order system. So we'll be using those things now, and trying to and we'll try to understand we'll try to solve these questions here. All right. So the first question is, in the circuit shown below, what is the value of the current supplied by the voltage source? Okay. So you see, this is the voltage source, right? This is the voltage source here, and this circuit is the R. There's a resistor here. There's an inductor here. There's a capacitor also here, right? It's a second order circuit. It's a complicated circuit. So definitely, definitely what will we do? We need to find out what is the current supplied by the voltage source as a function of time, right? Then in that case, there are two ways to solve this question. You can write the derivatives, basically differential equation of this particular circuit and then solve it, and that is also a way, but an easier way, and the way that we learned in the week 12, and that is to convert everything in terms of phasor, to write everything in terms of phasor, and then try to understand what is the current, right? Cool. Hmm, so let's do that. So you see, in terms of phasor, what do we do first? How do we write a phasor for this source here? When we try to replace it by its equivalent phasor, what will we do? Sine of 10t. It's a time domain signal, right? It's a time domain voltage source. The amplitude of this sine is 1, right? Amplitude is 1, and this is the time dependent. This is sine of omega t, right? Sine of 1 into sine of omega t. Omega is 10, right? And correct. Omega is 10, and amplitude is 1. Correct. Now, when we replace a source with its phasor representation, what do? We only retain the magnitude, right? We retain the magnitude 1, right? The magnitude has to be retained, and then there is an angle associated with that magnitude, right? That angle is what? That angle is
Zero.
supposed to be phi, right? The phase, extra phase of the extra phase lag or lead in the voltage source or signal source, whatever it is. But since this phi here is 0, right? So that is why this angle is 0, correct?
Yes.
Yes. Now I may as well write it simply 1, right? Because 1 angle 0 is simply 1, right?
Yes.
You see, in general, when we do this, when we replace things with their phasor notation, when we generally assume that the source is of the type cos, okay, that the source is of type 1 of cos of 10t. Uh, Basically, the source has to be of the form like this, not sine but cos of some omega t plus phi. Okay, we generally assume that this is the kind of source, because ultimately you remember that please recall that when we were trying to understand, when we were trying to move from the time domain representation to the phasor representation, we were taking e to the power j of omega t, right? And we were taking the, saying that the real part of that is to be taken, right? Now real part of e to the power j omega t, you remember this e to the power j omega t plus phi. This was the one that we were seeing, and then we saw that a real part of this has to be taken, right? So this how will this look? Real of cos of omega t plus phi plus sine of omega t plus phi, right? Sorry.
Yes.
Right, this is how it will look. So basically this is inside it, okay? This is how it will look, right? And we were only worried about the real part, isn't it? So ultimately this when we generally denote this this voltage source or current, so whatever it is, when we try to replace it into, when we try to transform it or derive its phasor form, we generally convert this whatever it is here into cos of something, okay? So what will this become? Cos of,
10t plus 90.
yes, this will become, so sine of 10t will be equal to cos of 90 minus 10t, right?
Okay, sir.
Or in other words, it will become cos of, let's replace everything in terms of not degree but radian. So this is pi by 2, right? So this is 10t minus pi by 2, isn't it?
Okay, sir.
Yes. So in that case, what is the phase now? So now the phase is actually, this is 1.
Minus 9.
So it is 1 angle minus pi by 2, isn't it?
Yes, sir.
Right. So this is the phasor for this one. So this can be replaced with, let me use another color. So this can be replaced with 1 angle minus
Pi by 2.
pi by 2. Cool. This is done. Now tell me, since we have the value of omega here, I can find the equivalent impedance, right? the phasor impedance of this, the impedance of this 1 Henry inductor, right? I can do
Yes.
that. So what will that be? This will be j
J10.
omega L, right? So j times 10 times
1.
1. So that will be j10,
J10.
correct? Similarly,
Yes.
this will be 1 over j omega c, right? Which will become 1 over j times 10 times 0.01, right?
Yes, sir.
Which will be how much? It will be 0.1. So 10 minus 10j, right?
Yes, sir.
It will be minus 10j. So this is what? This is minus 10j. So resistors, are these also changed or this remains the same?
Sir, it will be same.
Yes, it will be remaining the same because there is no frequency dependence in resistors, right?
Yes, sir.
Now since we have everything, let's make an equivalent picture here. So this guy here, it will look like this. That we have a voltage source here, and we have a resistor here. We have another resistor here. Then we have a impedance here, and we have another impedance here. Okay, this is like this. So this is this impedance is 5 ohms. This impedance is 5 ohms. This is 1 angle minus pi by 2. This is j times 10. This is minus j times 10. Correct?
Okay, sir.
Yes. Now tell me what will be the. Now this is very easy to solve, right? The circuit. What will be the current now? This I. So this Is is equal to Vs. So this is Vs, by the way. Vs upon. So this will be parallel combination of this and this, right?
Yes, sir.
So this is one and this whole guy is one. So tell me what is the impedance, total impedance here? Parallel
So
combination
2.5.
of these two. Yes, because these two cancel each other, right? These two cancel each other. J10 and minus J10 becomes 0, isn't it? So it
Yes.
is only parallel combination of 5 and 5. So this becomes 5 and 5 becomes how much? It
2.5.
becomes 2.5. So this is 1 by 2.5, and the angle is again minus pi by 2 only, isn't it? So this is actually how
0.
much? 0.4, no?
Yes, sir. Angle minus pi by 2.
0.4 minus pi by 2. So what will be if we try to go, so this is basically amperes, right? So if we try to change it back to the this thing into the time domain form, what will we do? We'll simply take the magnitude here. This is 0.4 cos of
Yes. 10t
omega
minus
t
pi by 2.
minus pi by 2 amperes, right? Isn't it?
Okay, sir.
Yeah. So this is an easy thing to do, right?
Okay, sir.
Yeah. So is there any doubt in this question? I guess not. There shouldn't be anything. This was very straightforward. So
So
we're
for
moving on. Yeah.
so regarding this voltage source, we have to always convert it to
Yeah.
cos.
Always replace it into in terms of cost. Then it will become easy for you to handle because I mean if you are very well versed with these things, you might not be you might not even need sometimes, but it's always a good strategy to change every source in terms of cost. Okay, and then proceed.
Yes, sir.
Otherwise, you might end up in trouble.
That means it is beneficial but not necessary.
No, no. I mean, it is actually if you actually think in terms of the algorithm, it is always necessary. Okay, but sometimes you might not need it if you know what you're doing. Because we are when we derive this phasor, it is always real of, right? When we are deriving it, we were back of our mind, we understood that we always have to take the real part of this, right? Not the imaginary part. The sign is actually the imaginary part of it and not the real part. So actually you should take it, but sometimes you might, because in this question we might not even need it. You see, there is only one source here. Even if we take in terms of sign, if we had taken one angle 0, ultimately there had been an angle 0 here, and simply it would have become sine of omega t, isn't it? But what I'm saying is, it's always Always do that. Always convert first into cos and then proceed further. So as you move along, you become, if you solve a lot of questions like this, you become very comfortable with this. You might not need.
Okay.
You might be able to look at the circuit directly and say what is what. All right. So problem number 2. This is what? So this is for the circuit shown in figure A, the value of current I1. You see, this is the circuit shown in figure A. Okay, this is the circuit. Now this current I1 here, because of this voltage source here, the I1 is how much? I1 is 2 angle 45 degree. Okay, so it is given in terms of phasor. Remember, even the voltage source here, this is in terms of phasor, right? The magnitude of the voltage, the amplitude of the voltage is 100, whereas the phase is 0. So in terms of time domain, what will be the voltage source here? It will
So
be
100 cos omega t.
correct. Very good. And this current here will be how much?
So 2 cos omega t plus 45.
Plus 45 degree,
45 degree.
isn't it? Very good. So this is clear. Now the question that is asked is that this is the situation that has been given to you. Okay. Now you do not know anything about this resistor or this capacitor. The values are not given to you. The only thing that you know is because of this voltage source here, the current that is going to appear here will be this much. Okay. Now find the value of current I2 for the circuit shown in figure B. Now based on this information, let me reduce the size. I hope it is visible now also.
Yes, sir. I can
Yes,
see it.
correct. So based on this information, the circuit that is given on top here, based on this circuit, can you say what will be the current I2 here in this branch here when the voltage is 50 angle 0 and this is applied at this port here? Can you say something about it? You do not know anything about the individual components. You see R1, R1, C1, R2, C2, L1, R3, L2, all these things are unknown to you. But you know that when this was excited using a voltage source which was placed in this branch here, the current which was observed in this branch here was equal to 2 angle 45, right?
Yes.
So now you have to say, based on this information, can you say what is the current I2 here when the voltage source is applied in this branch here?
Sir, I think we have to calculate the transfer function.
Is it? Do you need to calculate? Yeah, you need to calculate the transfer function. Yes, you need to calculate what is the transfer function between this point, in this voltage source, this voltage to this current, right? You need to have an idea of the transfer function, isn't it? So let's say what do you want to know? I1 by V, let's call it Vs. I1 by Vs is something, some random transfer function, right? Something,
Yes.
some numerator upon some denominator. I am talking in terms of Laplace transform. Do you know what is Laplace transform? It was not covered, but okay, so let me not go there. Let's only do in terms of j omega. Okay, so let's say it is some numerator which is a function of j omega divided by some denominator which is a function again of j omega. Okay, and this is a transfer function I1 by Vs. But now, and this has been given to you. I1 was given to you. I1 is how much? 2 angle 45. And this is 100 angle 0 degree, right? And
Yes.
omega actually is fixed. Omega is not given here, isn't it? You see, omega is not given here. Omega
Yes.
is not given here, right? Only the phase and this is given. So there is some omega. Let's call it omega naught here. And based on that, this is the information that has been given to you. Now, based on this, you have to find out a voltage. You see, the location of voltage source has changed, right? Voltage source and current is changed in the second figure.
Yes.
So what do you think we should do? So let me draw this picture in a slightly different way, and then it is also please let me tell you that the way now that I will be drawing my circuit is also a hint to solving this problem. You see, I will be doing it like this. Let's take
वो
R1.
पालगढ़ क्या गांव की बहू बनेगी इंडिया की इंस्पिरेशन मास्टर शेफ
Could you
इंडिया
please
स्ट्रीमिंग ओनली ऑन सोनी लिव
could you please mute yourself? Oh no, sorry, this was my fault. No, you can unmute yourself. This something was wrong with my at my end. You can unmute yourself. It's not a problem. Yeah. Okay, so this is R1. This is I will not replace it by 1 over j omega C1. Let's call it only C1 here. Okay. Then there is another capacitor C2, which is like this. Then there is R2 here. Then there is L1 here. Then there is L2 here. Okay. And there is R3 here. Now, are you getting any hint here with this particular representation? Okay, let me make it even easier. Let's not call this. Let's call it I2. Okay. Okay. Let's not do that. Let's call it some I1 only. So let me rename the terminals here. Let's call this terminal here 1. Okay. Let's call this terminal 1 prime. Let's call this terminal 2 and 2 prime. And now this voltage here is V1. Okay. And this current is some I2. Okay. So see, I simply have renamed this I1 is equal to I2. It is this I2 is not same as this I2. Okay, please do not think about this figure for a moment. Only think about the upper one. Please do not think about the lower figure for a moment. Okay, only think about the upper figure. I have simply redrawn the upper figure in this manner. Do you get any hint with this representation, with this way of redrawing the circuit?
It is similar to the two-port network questions.
Yes. So what do you think you should do? Okay, what about the circuit? I mean, what comments can you make about the circuit? Is this a linear network or a non-linear network? Which is whatever circuit is there inside this red dotted box, is the circuit linear or non-linear?
Yes, sir. It is linear, sir.
It is linear, right?
Yes.
So tell me, can you use any theorems for your benefit here? Any theorem for your benefit, which will help you in establishing a relationship? Okay, so by the way, tell me something. What is the relation between these two figures? So you see, you want to find out now so in between these two figures, what is different? Let me copy and then so in between these two figures, now what do you want to do? Do this. You want to find out what is the current I1 here, right? And you want have applied a voltage source here, which is 50 angle 0, right? This 100 angle 0, this 100 angle 0, and applied a voltage which is 50 angle 0 here, right? So tell me something, what do you think we should do?
Sir, I think reciprocity theorem.
Yes, very good. So this is what we need to use, reciprocity theorem here, because you see the circuit inside this dotted red dotted box here is linear. Okay, circuit inside this box is linear. Okay, and in the first instance, in the first case, we have applied a voltage source at this port here and observed a short circuit current at this port here, at port 2, right? Now
Yes,
in
sir.
the second case, I simply reversed the case. I reversed it. I have now applied a voltage source at the second terminal, at the second port, and I'm trying to observe what is the what is the short circuit current at the first port, isn't it? So the
Yes.
relationship I know, isn't it? I know the relationship. This is since this is a reciprocal network, we know that I1, the short circuit current due to a voltage due to a the short circuit current observed at port 2 because of the applied voltage at port 1 is what? Why? What is that? Tell me in terms of Y parameters. What is it? What is I2 by V1? Is same
I2
as
by V1, Y21.
Y21, isn't it? It is Y21, right?
Yes.
Yes. And it is also Y21 is how much? It is 2 angle 45, right? Divided by 100 angle 0. This is Y21. Okay. And we know that Y21 is also equal to Y12, right?
Yes.
For so okay, let
Or
me do this. Y21 is actually equal to Y12 for reciprocal
networks.
networks. And we know that any linear time invariant network is also reciprocal, right?
Okay, sir.
Isn't it? So that is why not any linear yeah, so basically any network which consists only of resistors, inductors and capacitors is also always a reciprocal network. So that is why in this case what is y12? Tell me, what is y12? Y12 is indeed equal to what in this
I1
figure?
by V2.
I1 by V2, right?
V2.
Which is equal to how much? I1 we want to calculate and V2 we know, right? So this has to be equal to 2 angle 45 degree divided by 100
100.
angle 0 degree, and what is I1 in that case? 2 angle 45 divided by 100 angle 0 degree multiplied by 50 angle 0 degree, right? This is 50, isn't it? So now this is
Yes.
equal to how much? 1 angle
45.
45 degree, right? So what will be the current here? It will be 1 cos
Okay.
of omega t
Omega T plus
plus
45.
45 degree, and this much amperes. Okay.
Okay, sir.
Yes. Cool. So I hope you understood this question. So this
Okay,
was
sir.
a good question to revise two concepts, basically phasors and reciprocity. Moving on. Okay. Find the phasor diagram for the circuit shown below. So we need to find out what is the phasor diagram for this circuit. So tell me what will be the phasor diagram. So how do you draw the phasor diagram? You assume that voltage source here, since nothing is given, you assume that the voltage source here is at angle 0 degree. Okay,
Yes, sir.
where there will be
This was
some
the
magnitude.
reference phasor.
Yeah, come again.
Sir, voltage source will be assumed to be the reference phasor, sir.
Yes, you assume that the voltage source is at reference phase. Basically reference phase is the same as 0 degree, right? So you
Yes.
assume that the magnitude of the voltage source is mod of Vs and then the angle is 0 degree. Based on that, now you have to find out what will be the different phases for VR, VL and VC. So tell me, how will you do that? So tell me, what is VR?
So VR will be in phase with VS.
How?
Sir.
Why? Why should it be? Why should VR be in phase with VS?
Sir.
The voltage across a resistor is in phase with the current across current through the resistor. Okay.
Okay, sir. Okay, sir.
Yeah, the current through the resistor will always be in phase with the voltage through the voltage across the resistor. That is definitely sure. So tell me what is VR. So for anything, we first need to find out what is the current, right? What is the
Yes, sir.
current? What is the current here? Which is IS. It's
For
zero
calculating
four.
current, we will need impedance.
Yeah, impedance is given, right? Of all the quantities, all the elements, the impedance is given. So what is IS? It's Vs upon.
Z.
So it's a series combination, right?
Yes, sir.
So it is 200 plus J
Plus 850.
1250 minus J 450, right?
Yes, sir.
Which then becomes Vs divided by 200 plus J 800,
800.
correct? So
Okay,
what
sir.
this will be? This will be mod of Vs angle 0 degree divided by 200 into 1 plus J 4, right?
Yes, sir.
So what will be the angle of this guy? Mod of Vs divided by 200. So this is again
75.96.
0 degree divided by, what is the magnitude of this? 16 plus 1, 17, root over 17, right? The angle will be how much? Angle will be,
75.96.
yeah, that is, but let's do it in terms of this tan inverse of 4 by 1, tan inverse of 4, right? So if you find out the current would be how much? So this will be mod of Vs divided by 200, which will be the magnitude. Okay, 200 root 70, this will be magnitude, and the angle would be minus of tan inverse 4, right?
Okay, sir.
Isn't it?
Yes, sir. Yes, sir.
Correct. So the current is what? Current is supposed to be below the phase, right? Below the reference phase. Current is at negative phase. You see minus of tan inverse 4. This will have negative phase, isn't it? So tell me,
Yes.
if the current has the negative phase, what will the voltage VR? What will the voltage VR phase will be? It will
It
also be
will also.
negative, right?
Yes, sir.
Right. So if we have a, so now to, let's start doing it. So if we have a IS VS like this, so VR should be below, right?
Yes, sir.
It should be below, like this somewhere. It should be, VR should be here, right?
Yes, sir.
Now, now let's find what is VL. What is VL? VL is what? The current through the inductor, sorry, voltage across the inductor, right? We know that the voltage across the inductor is always 90 degree ahead
Ahead,
of
leading.
leading the current, right?
Yes, sir.
Now the current is also in the same as VR, right? The current would be somewhere here. I mean like this.
Yes, sir.
Let's call this some IS. This is IS, okay?
Yes, sir.
So this is IS. Then in that case, 90 degree ahead of this would be the inductor current, right? Inductor
Yes, sir.
voltage. So it should be somewhere like this, or somewhere like this, right? And this would be 90 degree ahead. So this will be VL, correct?
Yes, sir.
And we know that the voltage across the capacitor is 90 degree
Lagging the current.
lagging, 90 is at a 90 degree lag compared to current, right? So it should be where?
Sir, in the third quadrant.
Like this, right?
Yes, sir.
It is VC. So which one is the correct out of all the four?
A.
Yes, A is correct, right?
Yes, sir.
So now you understand how to find out the phases, phasor diagram. So this was also taught to you maybe in standard 12th, right? Standard 12th there is a course AC circuits, AC something is there, right? In that this is there, phasor thing is there, but that time we didn't learn it very well. But now it is our bread and butter. So phasor thing, please be very comfortable with it. I have some more questions on that. to make you comfortable. This is very important, phasor. All right. Again, the same kind of question. Phasor diagram. 1 second. In the circuit shown below, V1 is this much, V2 is this much. So basically in this circuit we have V1 equal to sine t volt, V2 is equal to 2 sine t plus 60° volt. Then the phasor diagram for the circuit shown below will be, yes, tell me, how will the phasor diagram look like? First of all, tell me what will be the position of V1 and V2.
So we have to keep V1 in the horizontal position along the x-axis.
Yes, let's do that. Let's do that. This is V1, okay, and then V2 will be 60° above, right?
Yes, sir.
This is angle is 60°. This is V2, right? The magnitude is also 2 times for V2, right? So V2 will be larger compared to V1, right? So let's do this. Isn't it? This would be something like this. Okay.
Okay, sir.
And now tell me what will be the voltage across the. So what do they want to find us? What do they want us to find? So they want us to find the voltage across the capacitor. Okay. So tell me.
Sir, first we have to first find the net voltage.
Yes.
Applied.
Yes, tell me.
By triangle of addition or parallelogram, whichever.
Yeah, so tell me what will that be? How will you do? So basically, you know that in terms of phasor, you can simply add it, right? You can simply, so if there is a phasor, you simply do this. Yeah, you are correct. You have to do whatever you are saying, but so yeah, so what will that be? V1 minus, so what will be the current, by the way, in this branch? V1 minus V2 divided by 1 plus whatever the impedance of this. So tell me what will be the impedance of this 0.5 guy, 0.5 farad guy? This will be,
sir, 1 by j omega 0.5.
1 by j times 0.5 and omega is 1, right? So no worries there. So this will be 2 minus 2j, right?
Okay, sir.
This is minus 2j. Yeah.
Yes.
Now what do we want to do? Want to find out V1 minus V2 upon 1 minus 2j, right? That will be the current. Okay. And then what will be the voltage across the capacitor?
So this multiplied by the capacitive impedance.
Like this, right?
Yes, sir.
Isn't it? So
Yes.
we first have to find out what is V1 minus V2. So what is V1 minus V2?
V1 minus V2. सर ओके सर पोलर फॉर्म में डालना पड़ेगा.
Yes, so it will be like this, somewhere here, right? No, don't solve it. I'm just trying to. You can always find the numerical answer. That's okay. I just want to find out the. Just want to motivate the methods. Okay. So minus V2 will be somewhere here. So this will be somewhere here, right? Minus V2. So okay, let me. Color. Yeah, this is minus V2, right? And then triangle of addition would be can be applied, right? So this will be somewhere like here, equivalent V1 minus V2, right?
Okay, sir.
Correct. And now what is now you have to what do you need to do for VC? First you need to find out the current, right? What is the current? 1 minus 2j is how much? This will be minus 2 upon 1. So the angle of this I am trying to find out. What is the angle of this? This is the tan inverse minus tan inverse of minus 2, right? The angle of 1 over 1 minus 2j, isn't it? So
Okay, sir.
what is the angle of 1 minus 2j? This guy. This is minus tan inverse of minus 2, right?
Yes, sir.
Yeah. So that is how much? Tan inverse of 2, isn't it?
Yes, sir.
So this will be basically moving in counterclockwise direction by, so this is how much? Tan inverse 2, and this tan inverse 2 will be adding to the angle of v1 minus v2, right? Isn't it?
Sir, it has a minus sign, no, sir.
No, you see, okay, let me rewrite it so that easily is able to. V1 minus V2 has some angle here, right? So by the way, tell me exactly what will be this angle. This is easy to do. This magnitude is 2, this magnitude is 1, okay, and then this angle is how much? This angle is 120 degree. So tell me where is, how much is this angle? I mean, this is this 90 degree or some angle, some other angle? Come on, this is very easy. So this is 1, this is 2, okay, this is 120 degrees, this is the diagonal. So how much is this angle here?
Sir, 60 degree.
Is it?
Sir, I'm not getting any idea to calculate that numerical value, sir.
Okay, I'm asking how much is this angle here? How much is
Sir,
this angle?
the whole angle is 120 degree.
This whole angle is 120 degree, right? This whole angle is 120 degree, yes. And this is the diagonal. This is a parallelogram. This whole guy is a parallelogram. So these two guys are congruent to each other, isn't it?
Okay, sir.
I mean, this is equal to this is equal to this, and this is a common guy. So the two sides are congruent to each other, isn't it? So tell me, what will be the situation? So this angle should be equal to this angle.
कौन सा, sir?
I'm saying these two triangles are
Yes.
congruent, right?
Okay, sir.
So I'm saying these two angles are equal.
Okay, sir.
Now this angle here is equal to which angle? Tell me.
Sir, the angle between the resultant and minus V2.
Between the resultant and minus V2, yes. This angle is equivalent to this angle, right?
Yes, sir.
And this angle here is equal to this angle.
Yes, sir.
Correct? Right? So tell
Yes, sir,
me,
yes.
what will be the so this angle is completely equal. Okay, so let's forget about this. Let's leave it like this. But anyway, this is some angle. Okay, you can easily calculate it. It's not a big deal. I will not go there. This will simply take up time. So, but this angle will be some. Sorry. This angle will be some angle, right? Some angle.
ठीक.
Okay. Now, what I'm saying is this is some negative degree angle. Okay, and then 1 over 1 minus 2j is tan inverse of 2, right?
Okay, sir.
The angle of this is equal to tan inverse of 2, correct?
Okay, sir.
Because it is minus or tan inverse of minus 2. That is why it is tan inverse of 2. Okay,
sir.
and this tan inverse of 2 will add in angle, right? With v1 minus v2 angle, right? What will be the overall angle of this? If you ignore this minus 2j here, So what will be the overall angle of this? This will be angle of V1 minus V2 minus angle of 1
Z.
minus 2j. Sorry, 1 over 1 minus 2j, right?
Yes, sir.
And what is angle of 1 minus 2j is,
Tan inverse 2.
right? Sorry, plus. And what is this is tan inverse of 2, right?
Yes, sir.
So that is why I'm saying it will add, right? So tan inverse of 2 will add with this quantity, right?
Okay, sir.
So now tell me, if it adds here, so where will that guy move? Where will the new phasor move? So this was
Sir,
original one. It will
counterclockwise
move.
direction.
It will move counterclockwise, right?
Yes, sir.
Now, where will it move? It will move somewhere here or here based upon the magnitude, based upon this angle, right?
Yes, sir.
So I will not worry about it. But let's say it has moved here somewhere. Okay. Now I have to multiply. Remember, I had to multiply with another minus 2j here. To find out this thing, to find out the voltage across the capacitor, right? So tell me, if you multiply by another minus 2j, what will that happen? What will that do? It will simply take it
Rotate
back
90.
90-degree, right? In the in the direction that I showed. So in this direction, right?
Yes, sir.
So it will move somewhere here, correct?
Okay, sir.
So tell me, where will the, so what is the final verdict in that case? Where is VC?
So in that case, sir, either option A or option B is correct, sir.
Correct. Either option A or option B is correct, and that you can simply find out by simply putting the numbers. What is the exact angle? Okay.
Okay,
But you
sir.
understand the idea here, right?
Yes, sir.
Yeah. So if you put the numbers, you will get the exact angle where it will be. Yes. So I guess that is okay, right? The idea here was to motivate, I mean, make you understand the way you have to deal with phasors. Okay, the angles, how things rotate. So phasors are very easy. Phasors actually are visualize. You can visualize phasors as simply vectors. Okay, which will be rotating in some with the angular velocity of omega, because that's how you have to assume understand these phasors. Okay, so another question here. For the circuit shown in the figure, the Thevenin voltage VTH and the impedance ZTH across the terminal A and B is, yes, you have to find out Thevenin's Thevenin's impedance here. What will you do? How do you find Thevenin's impedance and Thevenin's voltage?
Open circuiting all the current sources.
Okay, hold on. I will just turn on the lights. Yeah, you first for ZTH, what do? Open circuit all the current sources, short circuit all the voltage sources, right?
Yes, sir.
Okay, so first find out what is ZTH. So what is ZTH? For ZTH, yeah, I will just write it here. ZTH, open circuit all the current sources, independent current sources. Okay,
Okay, sir.
short circuit all the independent voltage sources, and then find the, then apply a test voltage, right? Apply a test voltage source find the current through the voltage source. Take the ratio, isn't it? That is what we do for ZTH. So tell me what we do. Again, we'll simply apply a voltage source here like this. This is some Vs, okay, and we have to find out what is this Is. We have to open circuit these two. So these two are current sources, by the way, okay.
Yes.
So these two are current sources. This is open circuit. This is open circuited. Tell me what is the equivalent impedance here.
So 20
All the
plus
three
this
guys are in. Yeah, all the three guys are in series, right?
series.
So what is ZTH? 20 plus J40 plus J20, which is J60 ohms. Okay.
Okay, sir.
And what is VTH? What do you do for VTH?
Sir,
Open circuit the terminals, right?
yes, sir.
And find the voltage across the terminals. Correct? So since you have two current sources here, two sources here, you have to do it for this. So you have open circuited it. Now you have to find out what is the voltage source, voltage like this, in this manner, right?
Yes, sir.
So this is VTH. So what is VTH? Tell me. You
So
can use
voltage around.
superposition here. You can use superposition here, right?
Okay.
But that is not required here, simply because you see since this is open circuited here, there can be no current flowing in this branch, right? So there is no information in this branch. So the current that is being flowing here, so it will simply circulate here. The current here will simply circulate here, right? So you can
Yes.
simply find out the voltage at this point due to this current source, at this point due to this current source here, and then simply take the difference, right?
Yes, sir.
Yeah. So what is the voltage at this point? This is equal to 3 angle 90 into J40, right?
Yes, sir.
So what is that? 3 into 40 is 120, right? And then angle 90, and the angle contributed because of this J40 would be another 90, right?
Yes, sir.
So it will be 180, correct?
Okay, sir.
Yeah, so this is basically the voltage here. Let's call it some V1. Okay, the V1 would be 3 angle 90 multiplied by J40. So 3 angle 90. So simply multiply. How do you multiply two polars? So first convert this J40 in terms of, again, angle. So this is 390, and this is what?
49.
40 90, right? So how do you multiply two polars? You simply take the magnitude of the product of the magnitudes, which is 120, sum of the angles, right?
Yes, sir.
So this is what I have done here. All right. What is the voltage here? V2. 40 angle 120, 180, right?
Okay, sir.
Again the same thing. Now what is VTH?
V1 minus V2.
V1 minus V2, which is equal to 80 angle 180, right?
Okay, sir.
And what is angle 180 equal to?
Angle
Minus, right? Minus 8. It is what is angle 180? It is simply minus sign, right? It is simply inverted, isn't it? 1 angle 180 is what? Minus 1. So 80 angle 180 is minus 80, right? Minus 80 volt. So it is the correct answer would be this one, right? This is the correct answer.
Okay, sir.
No, sorry. This is not the correct answer. The third one is the correct answer. Yeah. ZTH is 20 plus J60. Yeah, the third one is the correct answer. Cool.
Yes, sir.
Yeah. So moving on quickly. Yes. Now consider a circuit shown in the figure with a load impedance ZL. What value of ZL will absorb maximum power, maximum average power? So what do you do for this kind of question? Remember what do you do for average power, maximizing average power earlier?
So that maximum power transfer theorem.
Yes. So what do you do for maximum power transfer theorem? You have to do conjugate matching, right?
Okay, sir.
Basically matching, right? So there it was simply matching. If the load resistance becomes RL becomes equal to RS, in that situation you have maximum power transfer, right?
Yes, sir.
Here what do you do? Here you make sure that the load impedance is in
Conjugate.
conjugate of the source impedance. Isn't it? Correct. So let's do that. So how do you find out the source impedance first? You have to make sure that the average power is supplied to the ZL is maximized, right? So what will be the, so what do you do first? You have to make the Thevenin's equivalent, right, of this particular network here. So yes, find out the Thevenin's equivalent here. What will it be? What will be ZTH?
Sir, we have to apply test voltage. Then we
Yes, you have to apply test voltage by shorting this first, right? This will be shorted here, and then you have to apply test voltage. So apply test voltage and then say, wow, how much is this? So this is the same thing like this, right? So let me redraw it. It is 1 ohm is here, and then there is J1 ohm here, which is J times 1 here, plus minus Vx minus J1 here, right? Two Vx here, apply test voltage here. We test. What is the current I test here? Yes, what is the current I test here?
Sir, I have not calculated it yet, sir.
Okay, let's do that. So I test would be equal to how much? This current 2Vx plus or minus 2Vx rather, plus, since this current is going this way, so it will be minus 2Vx, right, plus whatever current is going here, isn't it? So how much current will be going here?
Sir, V test divided by Z equivalent.
Correct. So V test divided by Z equivalent. So what is Z equivalent here? This would be these two guys in parallel, right? J1 and J1 and 1 in parallel, which will be J1 times 1 divided by 1 plus J, right? So it will be 1J divided by J plus 1. This will be this parallel impedance plus 1 over
minus J.
1 over minus J, right?
Sir? It is already converted in the complex form, sir. No,
and then it will be inverse of this V test, right? Am I correct?
sir, here, sir, 1 by minus j, sir.
Yeah,
Okay,
this is
sir,
what is the problem with that?
sir,
Oh, yes. Sorry. Yes. Thank you. It will be simply minus j here. Right. Thank you. Is it now correct? Is it correct now?
yes, sir, I think so.
Yes. Yes. So it is minus 2vx plus, and this will be how much? So 1j minus j and plus minus j is again 1, right? 1 plus j inverse of this times v test, and is I test. So what is this? Minus 2vx plus, it is 1 plus j divided by, then this cancel, so it will 1 times v test, right? Now we have to find out what is vx. What is vx in terms of v test? What is this voltage in terms of v test? It is the
Sir,
voltage
which one?
division, right? Yeah. Tell me what we should do.
Sir, which voltage are you referring to, sir?
I'm asking about this voltage Vx because this current here is dependent upon Vx, right? It's
Yes,
a
sir.
voltage dependent current source here. So we have to find out what is Vx in terms of Vtest, right? So what is Vx in terms of Vtest? You see, it's a simple voltage division, right? The voltage here is Vtest. So it's a simple voltage division. So tell me what is that? Parallel combination of this, and there is this thing here, right? So what is that? In other words, you can simply find out the, since we have already have the current flowing through this, right? The current
Okay,
we
sir.
already have 1 plus j
Right.
times v test,
Okay,
right?
sir.
And that simply multiplied by the parallel impedance of this will give us vx, right? So it will be 1 plus j times v test, which is the current, this current here, correct? And this multiplied by the impedance 1j divided by 1 plus j, right? That will give us the vx. So this is gone. So it is simply equal to v test times 1j, right?
Yes.
This is vx. So replacing that here, if we replace that here, so it will become minus 2 times, we replace this value here, correct? It will become minus 2 times 1j times v test here plus 1 plus j times another v test here, and that is I test, correct? So tell me what is v test upon I test now? 1 over 1 plus j minus 2j, right? Which is 1 over 1 minus 2j, correct?
Okay, sir.
So this is our ZTH, isn't it?
Yes.
Okay, so how much is this? Can you replace it like this? So this will be 1 plus 2j divided by 1 plus 4, right? Or another one is 5. That is 1 plus 2j by 5. This is ZTH.
So 0.2 plus 0.4 j.
Yes. Now, what do we need to find out? What is VTH, right? We also need to find out VTH.
Yes, sir.
So what is VTH? How will you do that? Simply open it here. You open it here, and then you find out what is VTH, right? So again, tell me what is VTH.
VTH is
How much it will be? Yes, solve it quickly. Did you solve it? Did you solve it?
No, sir.
Solve it.
So first we have to apply KCL at this node above that inductor.
This node. Has to do that. Okay, so before that, should we do something else to make it slightly easier? You see, let's use some source transformation here. Okay, so this can be equivalently mentioned, right, written in terms of like this, right? If this is replaced by a current source, this voltage source, and the current source value will be 4 angle 0 degree, right?
Yes.
And this resistor will be again resisted like this, 1 ohms. Then this will be a parallel combination of this one also, right? And this will be J times 1 ohms plus minus Vx, right? This is the current minus J1, and this is the situation like this here, 2Vx. You want to find out this voltage Vth, right? See this whole things, it becomes equal to how much? Simple, 1 plus J, right? 1 plus J, isn't it? Oh sorry, this is a parallel combination of two resistors, right? The impedance, equivalent impedance becomes 1J divided by 1 plus J, right? You already saw it,
Yes, sir.
correct? And this multiplied by this 4 ohm, uh,
4 ampere.
okay, so sorry, this is 4 amperes, right? 4 amperes, and this is the situation. Now we'll again do source transformation here, right? The equivalent impedance of this would this was how much?
1J by 1 plus 1J.
Correct. This was 1J divided by 1 plus J, right?
Yes, sir.
So again we will do source transformation. Now we will do this again. It will come back as a this thing. Oh no. But if we do source transformation now, this will be a problem because we have a dependent source, so we cannot do source transformation anymore. Okay, so you'll have to live with this. Cannot do source transformation anymore. So it will be like this. So we cannot do any source transformation because why? Tell me. You see,
Sir, I
if we
don't.
because you see this voltage here, this is Vx, is actually needed, right? Here also, if we do source transformation here, this voltage will be lost, right? This
Yes.
voltage Vx will be lost, so we cannot transform it anymore. We will have to go with this only. Okay.
Okay, sir.
Yeah. So now we'll do KCL. All right. So tell me KCL at different nodes. So let's write KCL at this node. Okay. So what is the KCL at this node? Let's call it V1. Let's call it V2. By the way, V2 is equal to VTH, right? So we'll not call it V2, we'll call it VTH. So let's write KCL at V1. KCL at V1. What is that?
4 angle 0 plus
4 angle 0
2Vx.
plus
2Vx.
2Vx. Is it?
Yes, sir. This is a dependent current source, sir.
Yes. Plus 2Vx. Yes.
Is
And
equal to
what is Vx, by the way? Vx is equal to V1. So let's call it Vx only. Okay. at Vx, 2Vx is equal to what?
Is equal to sir Vx by J by 1 plus J.
Right?
Okay, sir.
Yeah. And this is KCL at this node, right? So we'll directly find out what is Vx, right? With this. What is
Okay, sir.
Vx?
सर ओके सर पोलर और ये कन्वर्ट करना पड़ेगा.
Yeah, do it now. So no, 4 angle 0 is nothing. 4 angle 0 is simply 4, okay?
Yes sir, 4 plus J0.
Yeah, so it is 4. So nothing to convert here. So it's simply how much? 4j plus, okay, so let's do this. 4 plus 4 equal to Vx 1 plus j divided by j minus 2, right? So what is Vx now? 1 minus j divided by j, so it's 4j divided by 1 minus j, right?
Okay sir.
This is this much. This is Vx. So what is Vth? What is Vth? This is Vx plus this capacitor is how much? Minus J1, right? So the
Yes.
current is moving in this way. So the drop across this capacitor will be added, right? So it will be Vx plus drop across this capacitor, drop across this capacitor, right?
Okay,
That will be how much? Minus J1 times
2Vx.
2Vx, right? So what is
Yes,
Vx? 4j divided by 1 minus j, isn't it?
okay sir.
So how much is that? Oh, I shouldn't have converted it like this. 2Vx only. Yeah. So now take Vx common. So what is this?
1 minus 2J.
1 minus 2j. So what is Vth is equal to 4j divided by 1 minus j into 1 minus 2j. Correct? What is that? 4j into 1 minus 2j into 1 plus j divided by 2. Isn't it? So 2. And what is this? 2j into 1 minus 2j plus into 1 plus j is 1, and then plus 2, right? And then minus 2j plus j is minus j. This is equal to 2j into 3 plus 3 minus j, isn't it? So now we have Vth and we have Zth. So what is our Vth? Final Vth is equal to 2j into 3 minus j. What is our Zth? 1 plus 2j by 5, right?
Okay sir.
So what will be the value of ZL for maximum power transfer here?
ZL sir, conjugate of that
Yes.
one.
Correct? It should be 1 minus 2j divided by 5, right?
Yes.
So is that clear now?
Yes sir.
Yeah. So if we probably didn't have to find out what is the value of Vth. By the way, now that we have the value of Vth, can you tell me what is the maximum power transferred? What is P max? What is P average max?
Sir, V square by ZL.
No, it is mod of V square. It is mod of V square by ZL, right? And that too,
Yes.
maximum power is how much? 4, right?
Okay sir.
How much is that? 4 or 2? Tell me. Come on, fast.
Sir, I don't remember that. I think I have to look up in the books.
Okay, so let's derive it. So what is P average? P average is how much? V square upon mod of V square upon 2ZL, right? So if you have a voltage source here, if you have one ZL here and another ZL conjugate here, so what is the total current here? This is Vs, okay. So this is Vs divided by ZL plus ZL conjugate. This is the total current that you have, right?
Yes, sir.
Yes. This is I. So what is the power? Power is real of V times I conjugate, right?
Okay, sir.
So this is real of what is V across this? This is Vs into ZL upon ZL plus ZL conjugate,
Yes.
right? And into I conjugate. What is I conjugate? Vs conjugate divided by ZL plus ZS, sorry, ZL conjugate, right? So by the way, there is a half here. There is a half factor involved here, okay? So it is half of this. Yeah, so tell me how much is this now? Vs into Vs conjugate becomes mod of Vs square, right? Multiplied by ZL divided by, oh sorry, this is ZL conjugate by the way. This is ZL conjugate divided by
ZL plus ZL conjugate square.
so this is, and this is conjugate of this, right? This again becomes ZL plus ZL conjugate, the mod of that whole square, right?
Okay, sir.
Yeah, so how much is that? Since ZL and ZL conjugate are basically, what will this become?
Same magnitude. They have same magnitude.
Yeah, they have same magnitude. So basically this will become a real part of ZL, right? Come on, tell me what will be the value here? So since Vs square is anyway real now, you can as well take it out of the real guy here. Becomes ZL conjugate divided by ZL plus ZL conjugate the whole square. How much will this be?
सर सॉल्व कर दीजिए सर, आप समझ में नहीं आ रहा है।
Okay.
कॉम्प्लेक्स नंबर में बहुत दिक्कत है सर।
Okay. So this is how much? This is let's write it here again. I is equal to, yeah, sorry, power is equal to now. This is the delivered average power, by the way. This is average power, and since I have already assumed conjugate matching, it is also max. Okay, so what is this? Is equal to half of mod of Vs square into real of ZL conjugate divided by ZL plus ZL conjugate mod square, right? Now since ZL plus ZL conjugate is always a real number, it is real number, right? ZL plus ZL conjugate is always a real number.
Yes sir, the imaginary part cancel out.
Yes, correct. So so you can always you can as well take it out, right? Correct? Is it right? Is it correct? Is it correct?
Yes, sir.
Just
Yes,
think.
sir.
Yeah. So what I want you to do is, I want you to use this formula here and find out what is the maximum average power that is being delivered here. Okay, go back and try to find out how much is the maximum average power. Since you have everything here right now, since you have Vs is what, Vth, right? Vs is Vth. So you have all those things. Based on that, you can go and and find out what is the maximum average power that is being delivered here. Okay.
Okay, sir.
Hmm. Okay. Yeah, it's the same question. Okay, it's the same question, but in this question we have been asked what is the value of maximum average power absorbed by the load. It's the same thing. Okay, the same question as last one. So
Okay,
I'll
sir.
not solve this. You can solve this on your own. Ah, okay. What is the magnitude and phase plot of the voltage across the inductor in the circuit shown below? Yeah. So how will you do that? So they have been asking what is the voltage and what is the magnitude and the phase plot of the voltage across the inductor. So tell me, what is the voltage across the inductor? What is the formula? What will it look like?
V is equal to L di by dt.
In terms of phasors. Since you want to find out the frequency response, right? You want to find out what is the magnitude as a function of frequency. You have to go into phasors, right?
Okay, sir. V is
So
equal
it
to I
is
into j omega L.
correct. I into j omega L. What is I? I is Vh divided by R1 plus j omega L plus 1 over j omega
J omega.
C and into j omega L, right? This
Yes,
is
sir.
the VL, right?
Yes, sir.
So what is this? What is the phase of this VL? Phases. This guy is 90 degree, right?
Okay, sir.
Numerator is 90 degree, right?
Yes, sir.
So phase is numerator minus denominator, right? So phase is the angle of numerator minus angle of denominator. So what is the angle of numerator? It is 90 degree always. So this is j omega L, right?
Yes, sir.
And then minus of angle of denominator, which is tan inverse
By
of
omega L plus 1 by omega C by R.
omega L minus, na? It is not minus omega C, right? 1 over omega C. Since j, this is 1 over j, right? So if you do this, it becomes
Minus J.
minus j, right?
Yes, sir.
Minus j over omega c. And divided by r1,
R.
right?
Yes, sir.
Yeah, so this is the phase, right? And what is the magnitude? On the top it is Vs into omega L, right? Divided by
R1 square plus omega L minus 1 by omega C square under root, whole under root.
correct, something of this kind, right?
Okay, sir.
So how will this look like? So at a very low frequencies, when omega is very low, what is this? You can neglect this quantity, right? Omega is very low, then 1 over omega c will be very large, right?
Yes, sir.
So in that case, omega L can be neglected with respect to omega c, right?
Okay, sir.
And so equivalent at very low frequencies at omega is much less than I mean omega is very close to 0 at that time, this will become how much? Vs into omega L divided by root over r square plus 1 over omega c the whole square. This will be like this, right?
Okay, sir.
And if omega is very low, then it might be much greater than r square also, right? 1 over omega c square. Because omega is very low, so you can neglect this also. So this will become ultimately equal to omega square LC, right?
Yes.
So at
One
very
by
low
omega.
frequency, yeah, at very low frequency, what should you observe?
Omega square. Sir,
I mean,
it
it
will
should
be
increase, right? It should increase, right? At very low frequencies, the magnitude should be very low, right? It should be
yeah.
at, as omega is reducing, it should reduce. So as omega is increasing, it should go like this, right? Since omega is,
Yes, sir.
since this is directly proportional, right? I mean, this is omega square here. There's omega square term here, right?
Okay, sir.
So it should keep on going like this. So at very low frequency, it should increase. So it should be either this one or this one, right? At very low frequency, it should keep on increasing, right? At very low frequency, it should increase the magnitude at least. Okay.
Yes. Yes, sir.
At very high frequencies, what should happen? Very high frequencies. You please understand that at very high frequencies, what will happen? This omega c,
Omega
1 over omega c will be very less, right? Omega
Yes,
L will
sir.
dominate. So
Yes,
it
sir.
would be how much? It would be Vs mod of Vs at omega tending to infinity. It should be how much? Mod of Vs into omega L magnitude, or only omega L only, divided by root over r square plus omega L the whole square, right? Now at very high frequency, r square will also be very less than omega L, right? So that
Okay, sir.
mod of Vs into omega L divided by, this will be, r can be neglected, so it will be omega L square under root, which will be simply omega L only. So they will simply cancel each other, right?
Okay,
So
sir.
at very high frequencies, VL will be equal to Vs, right? So it
Okay,
should
sir.
be a constant at high frequencies. So it should be constant again at high frequencies, isn't it?
Okay,
The
sir.
magnitude at very low, and now at intermediate frequencies, what should happen? At intermediate frequency, by that what I mean, at the resonant frequency where omega L is equal to 1 over omega c. At that time, this quantity here will go to 0, right?
Okay, sir.
And then this guy here, omega VL, will become larger, right? Larger compared to Vs. It might become larger compared to Vs. So this is a possible magnitude transfer function here. Okay, this is the possible magnitude of VL. Okay,
Okay, sir.
but now we also have to find out which phase. What will the phase characteristic of this VL? So what is the phase here? 90 minus tan inverse 1 omega L minus 1 over omega c by R1, right?
Yes, sir.
So what is that? At very low frequency, when omega is very less, or when omega is actually equal to 0, okay, at very low frequency when omega is actually equal to 0, what will be the this thing? What will be the angle here? This, what will be the
1
angle
by.
here? 1 by 0 is infinity, right?
Yes, sir.
So 1 by minus 1 by infinity, sorry, minus 1 by 0 is minus infinity, right?
Okay.
So this is minus 1 by 0, so it is minus infinity, right? This will go to minus infinity,
Okay, sir.
correct? So what is tan inverse of minus infinity? It is minus 90 degrees, isn't it?
Okay, sir.
So you see tan theta, you remember, is minus pi by 2, it is plus pi by 2 here. It goes like this,
Yes, sir. Yes, sir.
correct? So
Yes, sir.
if at minus infinity, the angle of tan theta is minus pi by 2, right?
Yes, sir.
So it should be minus pi by 2 here, or minus 90. So how much will this become? 90 minus minus 90. It will be 180, right?
Okay, sir.
So it should start with 180 here, correct?
Okay, sir.
And at very high frequencies, when omega is very large, at that time, this quantity will be much larger, right?
Yes, sir.
So it will be infinity, tan inverse of infinity. What is that?
Pi by 2.
Correct. 90 minus 90, right? Which is equal to 0. So it should be going to 0 asymptotically, right?
Yes.
So again, this is the correct. So this is the correct response. Okay.
Okay, sir.
Mm. Similarly, questions these two questions are again similar. Oh, okay. Same question. I have taken 2 times. Again, the same. This question is also similar. You can work through it in your own time. So this is pretty much what I wanted to discuss today. There will be an extra class on Thursday. Please attend. There I will be discussing some of the questions from previous year. Okay, that will be for your benefit if you want to appear in the examination conducted for this
Sure, sir.
particular
Sure, sir.
course. Yeah.
Sure, we will attend.
Yes. On Thursday we'll be having an extra class. It will be it is officially for 2 hours, but I will try to wrap it up in 1 hour, 1 hour 15 minutes. Okay. So please do attend that session. Okay. Okay. Thank you for today. I'll also
Thank you,
cover
sir.
some. I'll also do some revision of the earlier things which we have already studied. I have not posted the lecture for week 10 again because I thought since we are anyway having an extra class on 10 on Thursday, I will be covering that on Thursday itself. Okay, you can come with your doubts on that day if you have any doubt in the overall course. We'll be trying to address. I'll be addressing those questions. Okay. Okay.
Sure.
That's all.
Thank you.
Thank you for joining today.